Woohoo! Welcome back. Today we're going to be working with transformations of functions. To begin with, we're going to start with what I think is the simplest of transformations. We're going to talk about shifts. So this first problem, I've actually printed out what Desmos would display because I've got no good way to share this video with Desmos. So this is a picture that I copied from Desmos, and it has the graphs of f of x equals x squared. So let me label them so you can see this is x squared. G of x is x squared plus 2. And now we could take a look at the two other graphs, and hopefully I could convince you that since this point is the point 0, 2, that this is a strong candidate for x squared plus 2. And in fact, that it is x squared plus 2. And then because this point right here is 0, negative 3, though this is a strong candidate for x squared minus 3. So if you don't already have Desmos open, I encourage you to open it up. Try typing in these three functions, x squared plus 2, and x squared minus 3, just to see that you'll get the same results. And then we can compare what is going on. So the graph of f of x equals x squared is the red graph. And I'm going to underline it with red, and I know that not everyone is going to be able to take advantage of that. I know the red doesn't show up for everybody, but in case it does, I'll emphasize there, but I've also labeled it. We've got what I think of as the basic parabola. This is just a parabola. It looks like that. It's very exciting. It's a conic section. Woohoo. And then what happens is if we look at g of x, which is basically x squared, but slightly spicier, right? I've got x squared plus 2. That is, if you can see it, that is the blue curve. And can I convince you, as we're looking at this, that, pardon me, that's what's happened is we've taken x squared and we've simply shifted it up 2 units. Likewise, with h of x equals x squared minus 3, and that's the one, that's the graph again. If you can see that, it is in green. That what seems to happen for this one is that it has shifted down 3 units. And we can tell that most easily here on the y-axis because our point 0, 0 either shifts up to 0, 2 or down to 0, negative 3. And hopefully just by looking at this, but you could also see this with a table of values, you can see that simply adding 2 or subtracting 3 after the basic function is going to shift it. And I'm going to go ahead and, speaking of shifting, let me move this over here. Presto changeo. Give myself a little bit more room. What I'd like to do is look at a table of values where I have f and g and h all together. Let me see if I can squeeze in a little x. It's a little squishy, but let's take a look. So if x is 0, f of 0 would be 0 squared. G of 0 would be 0 squared plus 2. And h of 0 would be 0 squared minus 3. If x is 1, f would be 1 squared, that's 1. G would be 1 squared plus 2, that's 3. And h would be 1 squared minus 3 is negative 2. And we could compare, and we could say, it looks to me like to get from f to g, you're just adding 2. And to get from F to H, you're subtracting 3. And you could see that. We could go ahead and do something, a larger number. 4 squared is going to give me 16. 4 squared plus 2 is 16, plus 2 is 18. And 4 squared minus 3 is 16, minus 3 is 13. And just in working out the algebra or the arithmetic for that, we can see that this is literally adding 2 and this is subtracting 3. And the result is a shift that either moves up or down. Woohoo! Nice. Okay, so if you've gotten the rhythm for that, we're going to do this just a bunch of times. Next up, we have, somewhat sideways. Once again, f of x equals x squared is the red graph. That's the main graph is the red one right there in the middle. And this time I've got g of x, which equals x plus 2 squared, and h of x equals x minus 3 squared. Now, as you look at these, and again, I know it's hard to necessarily see the graph if you're looking on a very small video screen. So definitely open up Desmos and give this a try on your own. But we can take a look here. We can make guesses. If I have x plus 2, when I had plus 2 here, it went, right? This went up, and x squared minus 3 went down. The shift was up when it was plus 2 and down when it was minus 3. And so plus 2 I would expect to go to the right, and minus 3 I would expect to go to the left. However, if we look at the actual graphs, we can see that the vertex in the plain version, f of x, is at 0, 0. And then here, the green one, this vertex is at 3, 0. And this vertex is at negative 2, 0. And here's where it gets interesting. Because since I used 2 and 3 instead of 2 and 2, you can say, wait a minute, the 2, g of x, should correspond to this one. So as adding x plus 2 inside the parentheses didn't make it bigger, it shifted it to the left. This was a left shift because this went to negative 2, 0. And in fact, this is the blue graph. And then h of x is the one that shifted to the right. And a lot of people are really surprised by this, that the shift is backwards. This plus 2 means you go to the left, and this minus 3 means you go to the right. And let me try to explain why this happens. The reason this happens is because if before you square it, you are adding 2 to x, that allows x to be smaller. So if you are saving up some money and you want to buy something and someone gives you $20, you don't have to save up quite as much before you buy it, right? So if you add 2 to x inside of the function, it allows x to compensate. So x actually shifts smaller. If you're saving up for something and you find out that you forgot to pay your math bill and you've been letting the math run every day, and so you've got a really high bill, that means that you have to pay the math bill and you have to save up. So you end up having to save more. It forces x to get larger to compensate, right? It has to be 3. And then we subtract the 3, and that brings us to 0, which then gets squared. Same thing here. If it's x plus 2, if x is negative 2, negative 2 plus 2 is 0. So it compensates with a left shift and a right shift. Okay, so for this first video, just the shifts, what are the rules? So the rules are, if you have a plus a and a minus a. And this right here, I want to say a, in this case, is strictly greater than 0, right? So we're not doing plus a minus 3 because that's going to mess us up. So make sure a is positive. But if a is positive and you add it after the function, so you add it outside of the function, you square x and then you add 2, then that shifts the graph up a units. Does that make sense? You're shifting up a, whatever a is. So a is the number of units. And if you subtract a outside of the function, this shifts the graph. Which way? You got it, down a units. Now, what happens if you add the a or subtract the a inside the function, inside the parentheses? That forces x to compensate, so that shifts the graph left or right. So plus a shifts the graph to the left. And if you subtract a, this is going to shift the graph right a units. Okay, woohoo. So what does this all mean? Well, what this all means is that we're going to be able to go ahead and use this information. And so if we know what the graph of x squared is, or something else, then suddenly we can also graph all those other related graphs and just know that adding 2 or subtracting 3 inside or outside is not going to change the shape of the graph. It's just going to literally move it either to the left or to the right or up or down. So that's going to be the beginning of learning how to graph a lot of stuff with just knowing the basics. Okay, woohoo! That's the end of video 1. In the next video, we will talk about more exciting transformations of functions. Woohoo! Awesome. I will see you then. Until then, math on.